Einstein's relativity. Part 1. What is Einstein's theory of special relativity? Albert Einstein was credited with the development of the theory of relativity. What drove Einstein to come up with the theory of relativity? According to the narrative, near the beginning of his career, Einstein thought that Newtonian mechanics was no longer enough to reconcile the laws of classical mechanics with the laws of electromagnetic field. Einstein supposedly based his relativity from Galileo's relativity. Einstein's relativity goes as follows. According to Einstein's relativity, when a stone is dropped from the top of the mast of a moving ship, the stone will land directly at the foot of the mast of the ship. An observer on land looking at the moving ship will see the stone follow a curved path to land at the foot of the mast of the moving ship. Likewise, when a stone is dropped from the tower, the stone will land directly below the base of the tower. An observer looking at the tower will see the stone follow a curved path to fall directly below the base of the tower, this being that the Earth is in motion, spinning on its axis. The relativity from the aforementioned discussions is that things done in the stationary inertial frame of reference is the same as in the moving inertial frame of reference. Theory of special relativity. The term special in the theory of special relativity refers to a case of uniform motion or constant velocity. An example given in the book, Einstein, His Life and Universe, by Walter Isaacson, is that of a man in an armchair at home and a woman in an airplane flying smoothly above. Each can pour a cup of coffee, bounce a ball, or shine a flashlight and have the same laws of physics apply. According to the book, there is no way to determine which of them is in motion or at rest. The man in the armchair could consider himself at rest and the plane in motion, while the woman on the plane could consider herself at rest and the earth moving. It is said that there is supposedly no experiment that can prove who is right. Another example from another book is that if you are at rest and you toss a ball directly up from your hand, it will land directly on your hand. Also, if you throw a ball directly up from a moving train, the ball will also land directly on your hand. The examples mentioned was supposedly based from Galileo's book Dialogue concerning the two chief world systems. Galileo's book is about the argument between the Ptolemaic system where the Earth is in a standstill and is the center of the universe and the Copernican system where the Earth is orbiting the Sun. The argument of the Ptolemaic system is, why if the Earth is spinning that we do not notice it? We know that Galileo supported the Copernican system and provided examples in the book on why we cannot observe that the Earth is moving or spinning by providing an example of being in a main cabin below deck of a moving ship. From Galileo's book. Shut yourself up with some friend in the main cabin below decks on a large ship, and have with you some flies, butterflies, and other small flying animals. Have a large bowl of water with some fish in it, hang up a bottle that empties drop by drop into a wide vessel beneath it. With the ship standing still, observe carefully how the little animals fly with equal speed to all sides of the cabin. The fish swim indifferently in all directions. The drops fall into the vessel beneath, and, in throwing something to your friend, you need throw it no more strongly in one direction than another, the distances being equal. Jumping with your feet together, you pass equal spaces in all direction. When you have observed all these things carefully, have the ship proceed with any speed you like, so long as the motion is uniform and not fluctuating this way and that. You will discover not the least change in all the effects named, nor could you tell from any of them whether the ship was moving or standing still. Galileo Galilei, Dialogue concerning the two chief world systems, 1632, translated and with revised notes by Stillman Drake, pages 216 and 217. The two postulates of Einstein's theory of special relativity are: the first postulate, called the Principle of Relativity, is stated as follows: all physical laws have the same forms in all inertial frames. The second postulate, called the Principle of the Constancy of the Speed of Light, is stated as follows: the speed of light in free space is the same in all inertial frames. It does not depend on the motion of the source or the observer. The first postulate, called the Principle of Relativity, states that all physical laws have the same forms in all inertial frames. Einstein's principle of relativity was already illustrated in the example of dropping a stone from the top of the mast of a moving ship and dropping a stone from the tower. To reiterate, the relativity is that things done in the stationary inertial frame of reference is the same as in the moving inertial frame of reference. The second postulate, called the principle of the constancy of the speed of light, states that the speed of light in free space is the same in all inertial frames. It does not depend on the motion of the source or the observer. The narrative on the second postulate is as follows. According to Einstein, when he was 16 years old in 1895, he did a thought experiment about what it would be like to ride at the speed of light alongside a light beam. He revisited the same thought experiment 10 years later, in 1905. In the movie, Einstein's Big Idea by Nova, based on David Bodane's bestseller, E is equal to mc squared, it said that at one time Einstein was walking with his wife Mileva, near a river, when they saw a person in a boat. He said that they can see the waves moving through the water, but for that person in a boat, the waves created by the boat looks like static, as the person and the waves are traveling at the same speed. Einstein can see the waves moving through the water, but relative to that person, it just sits there. That is, light is like the wave. Thus, as relating to light, if he can catch up with the light looks static or frozen. Maxwell's idea is that light always moves away from you at 300 million meters per second, no matter whether you are in a standstill or you are traveling very fast. Einstein just accepted that as a fact. The speed of light never changes. In another narrative, Einstein was walking with his best friend Michel Besso. They were discussing the problem of light from every possible angle. As Einstein and Besso were discussing on how much time it would take light to reach them from the clocks of different distances, Einstein had a monumental insight. The speed of light never changes. But as he approached the speed of light, time itself slows down. According to Einstein, the speed of light is the same whether you are observing it in a standstill or you are moving very fast. The effect of moving very fast is that time slows down. There are two consequences of the theory of special relativity, that is, when traveling near or at the speed of light, we experience time dilation and length contraction. Einstein published his paper on his theory of special relativity in 1905.
Please give proper credit to the author for discussion of his ideas and theories. Thank you.